Service robots are required to carry out several tasks that involve manipulation of textile objects for making beds, ironing, or making the laundry. In this context, it is essential to evaluate the performance of solutions to enable progress. However, measuring such performance in robotic manipulation is challenging due to the wide variety of applications, objects, and robotic systems used. My thesis is about benchmarking cloth manipulation, and my objectives are to define evaluation methods to identify the strengths and weaknesses of manipulation solutions, and to implement manipulation skills that serve as baselines for the proposed benchmark. Benchmarks are useful tools for evaluating something by comparison, but when dealing with the formal object manipulation tasks, for example folding a t-shirt, we find that the same task can be performed in many different ways. For this evaluation to be fair, basic protocols must be defined indicating the objects to be used, the task and the expected result, and instructions on how to measure the result. The objects are an important part of benchmarks, since they determine the manipulation to perform. Also, the behavior of textiles under the same manipulation varies depending on their properties. For this reason, we have defined a cloth set to spread among the research community with household clothes as bathroom, bedroom, or kitchen items, such as towels, tablecloths, or bed sheets, in order to allow the development of different tasks. In addition, unlike rigid objects, textiles can adopt different states, so it is necessary to define not only the position in space, but also the configuration. To do this, we define protocols that serve as instructions on how the cloth should be placed, varying the complexity according to the visible parts of the clothing. In the context of benchmarking manipulation, the main question that arises is whether to evaluate the task result as a whole or the grasp as independent parts. For this reason, we have encoded manipulation tasks as graph representations with which we can identify the manipulations that are performed and how they influence throughout the execution of the task. In this context, we work on a task of placing flat cloths over a table starting from different initial grasping positions in order to see how they influence in the final result of a task, and therefore help to determine how we should evaluate the states according to the following steps of a task. With the help of this graph, we can also identify manipulation skills that are performed very often, as edge tracing. With the combination of various of these manipulation skills, we can implement entire tasks such as folding towels and spreading tablecloth, which will serve as baselines for comparing different strategies to perform the same task. We also proposed a benchmark with metrics for evaluating the quality of the result in order to quantify how well the tablecloth has been placed or how perfectly the towel has been folded.